Hello and welcome to Bits and Bots. Today we're chatting with AJ Asver, CEO of Parcha AI, about how they use agents in production. Here's a 1-minute teaser of what you'll see.
It's really easy to set up a demo of an agent, but reliably running an agent in production is pretty challenging. We take this operating procedure, we give it to our agent, we break it down into steps. Our agents are composed of smaller agents. The agent has actually gone through and verified all the steps that you saw in that SOP. It's checking on the business's website, it's learning about what the business does, it's carrying out all these steps, and then it's making a final assessment. I'm going to show you guys what happens when we run it. So you can see it's starting to build these agents right up here for all the different steps in the workflow. And so this is a really long prompt we send to Claude. It tells Claude what tools it has access to, and it tells it what decision to make next. We like to focus on reliability, on accuracy, and then on security. I think pretty much everyone in the space underestimated the amount of work that it takes to make it happen.
That's the teaser. Let's jump in. Hello, welcome to Bits and Bots, AI Builder Stories with Ankur, and special guest this week, AJ Asver, founder and CEO of Parcha AI.
Hey, how's it going, David and Ankur?
Really excited to have you here today. What's Parcha?
We work with fintech companies to help them automate their manual processes. With large language models, you can now essentially teach an AI agent how to follow a process that a human would follow and give it the same level of expertise and judgment through text and through language in order for it to carry out that process. So my co-founder and I, we used to work at Brex, and then we started this company because we realized, what if we could solve that last mile of automation, but using AI? Now we're able to solve those processes we couldn't at Brex using these AI agents. So a lot of companies have these documents that describe step by step how a human should carry out this process. And really our differentiator as a company is that we come in, we take your existing policies and procedures, and we convert that into an AI agent that runs using the same tools, same policies, same procedures. So it plugs right in and helps you immediately scale that team.
What's your framework for thinking about how humans plug into it?
So for us, a lot of the times when we talk to a customer, they have a human in an operating role carrying out this workflow. And most of the time, because it's a regulated industry that we're usually operating in, especially with fintechs, it's a well-documented workflow. There's literally a set of steps, 1, 2, 3, 4, 5, 6, 7, how to carry out this workflow, right? And what we do is we take that documentation and we give that to our AI. And then a human essentially becomes a quality assurance expert on that AI to see if it's doing the job well. And then eventually, once it's meeting the accuracy requirements of our end customer, we can run it completely autonomously. So we just send it jobs to do, and it just provides output. And maybe that output is like an approve or a reject. And that can go straight back into your case management system, or it can go straight back into your product. I see a world in which humans are working collaboratively with AI and giving them tasks to do, but not necessarily always kind of overseeing every step in the AI. And we are very much of the belief that we're trying to create a system that doesn't require human scaling or humans in the loop. Now, if our customers want to put a human in the loop, that's fine, but we're not building our products so that our services have humans in the loop.
Do you have an example you could show us of what these humans who are doing this role do today?
I'm going to share with you guys an example of an operating procedure that we use as a demo, and then how it's automated with an AI agent. This is a Google Doc that shows an example of what an operating procedure might look like. And an operating procedure is just a set of instructions you give a human team in order to carry out a process that's repeatable, consistent, reliable, and accurate. We've created this doc as an example of what this might look like. And in this case, it's for doing KYB, which is basically a know your business process that's required by regulators in order to make sure when you're onboarding a business onto your platform to transact, that that business is not carrying out any money laundering, it's not in any sanctioned countries, that the business is doing what it says it does, it's not in a restricted industry, and that the owners of the business are also real people, and they themselves are not in any way carrying out any illegal behavior or are sanctioned or are on any watch list, for example. Let's say you're Stripe, right? Stripe works with thousands or hundreds of thousands of businesses that use payments on Stripe. So when Stripe onboards one of those businesses, they have to carry out a set of procedures to make sure that business is compliant. The reason that you have to do this process is because money is getting moved around. And so there's lots of regulations involved there. So take Stripe as an example again. They might be onboarding a bunch of customers, and when they're doing that, they need to carry out this process in order to make sure those customers are compliant. Now, in Stripe's case, they've automated a lot of this process, and they've done it at scale, right, to like hundreds of thousands of customers. But when you look at fintechs that are new or maybe earlier stage, a lot of this stuff is still done very manually. And so this is an example of what a manual process might look like. If you want to automate this process before our product existed, you would probably get some vendors to do each one of these steps. And then you might have some internal tooling, or you might have a machine learning model that could approve or deny a customer. And we actually had that at Brex as well. But oftentimes there's going to be this in between, an approve or a deny, that you usually want to run a manual review for. And the reason for that is you don't want to miss out on customers that could be valuable to your business. The other challenge with machine learning models is a lot of times when you're doing an audit, you're talking to your compliance team, they want to see explanations of why you onboarded a customer. And machine learning models don't usually offer that. And so what we do is we take this operating procedure, we actually give it to our agent, we break it down into steps, we give those steps in text, like language, to our agent for our agent to carry out. And it uses the tools available to it to actually carry out that process. And what's magical about that for our customers is it's very approachable for an operations person who's used to writing these text documents to then provide that same document to an agent to carry it out in the same way they would provide it to a human to carry out. And they don't have to use a work process or a workflow automation tool. They don't have to learn how AI works. They don't really need to know any of that. All they're doing is editing text the way they were already. And so when you have these processes running, this is our kind of system here where we have a set of cases and we have some agents running. And so we're trying to onboard, for example, this company called M1. It's a fintech company. We can see here, if we ran one of these, and this is in our backend, the agent has actually gone through and verified all the steps that you saw in that SOP. So it's checking on the business's website. It's learning about what the business does. It's doing maybe a TIN check. And so it's carrying out all these steps, and then it's making a final kind of assessment on the business. And so that's the output. And occasionally the agent might hit some errors, right? And so when we see that, we can also allow the agent to self-correct as well. This is an example running our development environment and some recent testing we're doing. So not an exact reflection of what happens in production. And a lot of the work we're doing at the moment is to make sure it works reliably and accurately, but you get a sense of how it works, the output it might have at the end. And in this case, the agent will provide a report, a kind of detailed report of everything it's learned at every step.
So basically you take what's in that Google Doc that a human is doing today, these manual steps, and you give it to your system, which breaks it down into a series of steps that an agent performs automatically and then gives back its report. Is that right?
Yeah, that's correct. So we can look at another one that went through as well. This one, you can see it's actually gone through a bunch of the different steps. It's done a bunch of the different checks. And then at the end, it's providing its final recommendation.
This is so awesome.
And so this is newer agents we're testing right now. So as you can see, they're in progress. One of them came up with an error here. We're working on how to error correct some of our newer agents as well. You get a sense of how it works in the back end.
For listeners who are new to AI, agent sounds really complicated, fancy, sophisticated. Was wondering if you could show us very practically what an agent means and looks like, what the series of prompts is actually under the hood.
One of the coolest ways of showing that is I'll run an agent. You can see the terminal and actually see what's happening in the terminal as it runs. So let me set that up and show you, because I think one of the things that people might think is there's like this AI brain happening in the background, but what it actually is a bunch of back and forth between us and the large language model. Let's see how this works. So I'm going to run an agent. I'm going to run it to do a review of a company. In this case, we're going to say we're onboarding this company called Pedal. They're actually a credit card company. And the agent's going to do the onboarding process for them. So I'm going to click Run Agent. And what that's going to do is going to kick off the process of running this agent in our backend. Now I'm going to show you guys what happens when we run it. So you can see it's starting to build these agents right up here for all the different steps in the workflow. And now you can see the magic. And so this is a really long prompt we send to Claude, and it tells it how the agent works. A lot of system prompt engineering. It tells Claude what tools it has access to, and it tells it what decision to make next. And basically says, okay, you're going to carry out this SOP, which we have here. It's very similar to the one I showed you earlier in the Google Doc. And the last thing it says is determine which command to do next. And so then this green stuff is what Claude returns. It says, okay, well, to complete the KYC process, I need to first do this command. And I'm going to provide it with this input. And then it goes back to Claude. And then now it's loaded a worker agent, which is going to go through that process. And again, it's this really long system prompt with all the information that it needs. And then finally, at the end, it tells it what to do. And then the agent will respond and say, okay, these are all the different steps to do that one step. that one kind of step in the process, and I'm going to go carry all of these out. That's a very high level how it works. You can see that it's this back and forth between the backend experience and then generating these prompts, which then goes to the agent, which then comes back with a decision. And that's how it works. And then when it selects a tool, we actually go and run that tool to get data back as well.
When you say tool, I think what you mean is you give it basically a list of follow-up commands that it can do.
Yeah. So for example, here we have all these different tools, this list of different tools that an agent can carry out. It's one called address verification, watch list, company info loader, mid-desk verification. And then it picks which one to do next, which is going to load the info about the company. And it goes in and actually runs that tool. And then we see that this is the information that was loaded. And so that kind of gives you a sense of how it's working in the background. It's like pulling all that information out. And then it gives that back to the model, which then decides what to do next based on that information. So they'll say, okay, now I know this. What am I going to do next? Okay, I have the information. I'm going to go verify it. So the next step is it's going to say, okay, I'm going to go and do a business registration check. And that means it's actually going to this integration we have with Middesk, which does business registration checks. And it's going to go check for this domain, because this is the domain of the company. We just worked that out for the last info that we pulled. It's going to go check based on this domain. That's just an identifier for the business, whether the business has valid registration with a local enforcement, with local business registration. So that could be state registration. It could be a country's business registration system. So for example, most businesses in Silicon Valley are registered in Delaware. So it probably has a Delaware registration. So that's kind of how it works. And it's a constant back and forth, pulling data, understanding that data, putting that back in the model, then deciding what to do next.
So one question I have, it looks like the work plan that the agent shared for the user is linear, which makes sense. If I'm scanning through it, I don't want to look at a tree or whatever of all the steps the agent is taking. But I'm curious, behind the scenes, is the agent following a linear process, or is it some more complex data structure? Is it parallelizing some of these tasks? And then the programming nerdy part of this is, how do you actually encode the agent itself? Is it just some recursive structure that you've implemented? Do you use one of the frameworks? How do you think about that?
So right now, the agent, the way it works is we take every one of those operating procedures and we break it down into multiple pieces. And then each one of those pieces usually has a big chunk that it needs to do, like verifying the business owner, looking at the website. And we actually break that down and put that into another agent. And so our agents are composed of smaller agents. And the reason we do that is we want composability to be able to solve any level of complexity of task, all the way from a very straightforward 5-step process to like maybe a 20 or 30-step process. So you can think about it as an agent that has lots of worker agents that are doing the job in pieces. And then each one of those worker agents, to carry out those steps, it has access to a tool. And that tool is usually an integration that our client already uses to solve that problem. So maybe they are looking at data to do a tax ID check, or maybe they're looking at data to do a government ID verification, and they have an existing vendor like Persona. We'll plug into that same vendor, or Middesk or Alloy. We plug into them too, the same tools a person would use. And that's the whole idea, is that we plug in the same way a human is doing the task today. You asked about, is it linear today? So the way it works today is the agent steps through each step linear. But the primary reason we do that right now is we actually want to just be able to show our customers every step as it's running, especially during the testing phase, so they get a good sense of how it's working and give us feedback. But we're working on a new version of the agent right now where it can essentially do all of the tools in parallel. A more accurate model for it is a directed acyclic graph, because there are dependencies between steps. Like you need to retrieve a piece of information in step 1, and you might need to use that in step 2 or step 3. So you can't parallelize everything, but you can parallelize some parts of it.
Why use agents for this? Did you consider using rules or heuristics or other things for making those decisions?
The reason is very simple. We tried everything else at Brex and reached the limitations of what was possible. In the course of a year, we basically had a 200-person team across product engineering, data science, machine learning, working on this problem. And we know what the limitations are of existing tools. And the reality is that when you're trying to connect the dots between all these different processes and try to understand, is this business the business they say they are? Are they the same as the business that's in this document? Is that the same as this business owner? Is this business owner the same as what's in this watch list? It's really hard to do it with a set of well-defined kind of procedural tools. You need that judgment, and you need that ability to look at different pieces of data and connect the dots in a way that's much more language-based in order to carry it out. And the reason for that mostly is because a lot of these regulations were written for humans, right? They were written long before you had computer interfaces to do all of them. So for example, the Delaware registration document is a PDF, but it has a Delaware seal on it and all this information. It has a signature on it. And so taking that information and looking at it and understanding it is actually difficult to put into a robotic process automation tool or into a tool-based system where you're just pulling that data. You want to interpret that data first. And that's a big piece of how our product works. The other piece is that our agents really be able to decide what step to take next based on the information they have. So they can see like, oh, based on what I see so far, I need to escalate to the operator. Or based on what I see so far, I can skip this step and go on to the next step. And so being able to make those decisions on the fly is much like how a human carries out this process. And then the last reason I would say is that a lot of the times when operations folks are trying to automate these processes, it's very difficult to get engineering resources to do it, especially in the current climate where there's a massive focus on running really lean, on getting to good, strong unit economics. And during that time, a lot of your engineering resources get diverted towards building product and generating revenue. And so automation ends up becoming second priority. And if an operations person needs to get that engineering resources first, it definitely takes longer than if they can find a product where they can just plug in their existing policies and procedures and it just goes. Which is why, up until now, the solution was just hire lots of people. But in the current macroeconomic environment, that is also no longer really a viable solution.
So this sounds like a really intense, meaty engineering problem. It also seems like you have built quite a bit of a solution here. I'm curious, what are the biggest engineering challenges with the stack or architecture overall?
I think they will come down to three main areas. We like to focus on reliability, on accuracy, and then on security. So I can go for each one of those. It's really easy to set up a demo of an agent working that you can wow investors with and maybe show to some of your customers, but reliably running an agent in production is pretty challenging. Oftentimes you may get really frustrating errors, like the LLM will return you JSON, which is often how you interact with these LLMs when you're trying to create structured objects. And the JSON may be malformed. So there may be a missing quote or a missing comma. So you have to build a bunch of infrastructure to just make sure the JSON you get back can be parsed properly. But then sometimes the agent may also just pick the wrong tool, or it may pick a tool that doesn't exist, hallucinations, right? And so how do you control for that? And then oftentimes agents can get stuck in loops as well. And so that's a big piece to look out for. So a lot of the software engineering and the architecture we're building is around taking this LLM tool, which is a fairly raw tool, right? It's like text in, text out. In fact, it's probably like a very inefficient computer, if you think about it, right? Text in, text out, and making it into a reliable and accurate thought machine that you could use in production. And so that reliability piece is, I would say, a big one. It's where we spent a lot of time over the last few months, and having early customers that we can build the product with and get their feedback on and actually run it with real world data has been very, very helpful to do that. And there's some cool things we've been building that I can talk about in that space as well. One of the most recent ones is self-healing agents. So when the agent makes an error, actually helping it self-correct and move on to the next step.
I've read a bunch of papers on if a LLM makes a mistake, you feed the same thing back in and just ask it to fix the mistakes, it does better. Is that the type of approach you're taking for self-healing or other things?
Yeah, it is very similar, actually. The inspiration came from just how we use ChatGPT. And when ChatGPT doesn't provide a good answer, you give it feedback, right? And you say like, hey, actually, this is close, but can you do X, Y, and Z? Well, it turns out you can do the same thing with an agent, where you essentially wrap the errors you're seeing from the agent into a very human readable prompt that you send back to the agent to give it encouragement to do better, essentially, and show it what it did wrong. And by using that loop, you can error correct your agent. And the cool thing is, if you do it by using the human prompt, it's actually much more reliable because the RLHF training that an LLM has gone through makes it want to align with what humans want, right? And so the more you can say as a human inside the program, hey, you made this mistake, can you fix it? And the more likely it is to fix itself. So that's something we use as a pretty cool way of error correcting.
And how do you measure this stuff?
It's challenging, I would say. And part of the reason why is because every time the LLM responds, it has different responses. But we have our own benchmarking system that we built. We have our own benchmarking specific categories that we look for. So we benchmark against planning, against execution, accuracy, and then reasoning. And we basically benchmark by getting data from our customers and getting our own data and running that hundreds or thousands of times to see what the outcomes are and see which ones match and which ones don't. We use some tools to help us with this as well. Langsmith is a cool tool we've been using recently that helps with going and looking through traces of the agent and seeing which prompts work and which ones didn't. But a lot of the actual benchmarking system we built in-house.
In terms of the software itself, are there any frameworks or tools that you use, or are you calling Claude's API directly?
We're big fans of LangChain. We use it for a lot of our LLM interoperability. What that means is LangChain provides a pretty standardized set of APIs that you can use to call different LLMs. This is valuable to us because we actually use different language models for different tasks. So Claude is what we use for our core reasoning and the way the agent decides what step to take next. But within our tools, there's sometimes we need to extract data from documents where we might use GPT-4. Or we might use Anthropic's 100K sized token completion. So that's basically a version of Claude that can take in a much larger prompt. For example, the contents of a document. And so what LangChain is really great at is it has a bunch of infrastructure to basically allow for that interoperability. We did start by building agents using some of LangChain's tools as well, but we found very quickly that we wanted to customize and build it really in our own stack in order for us to build it to our needs and our specifications. And so we don't use LangChain as much for that, but certainly for that interoperability between LLMs, it's very useful.
Awesome. I think we digressed a little bit on your list of top 3 challenges. So the first one, super interesting, was consistency, reliability, and you're saying the other 2 were?
Accuracy and security. Yeah. So accuracy is the next one. And that's really about making sure the data we provide to the agent and also the data that the agent is reasoning over is accurate and reducing the risk of hallucinations. So again, benchmarking is really valuable here. We actually benchmark against lots of different models to work out which one to use for a particular tool. And then the other thing we also do is we try to split up the various different pieces of going through a process into as many concrete atomic steps as possible. The reason why is because if you overload a prompt with too much content and ask an agent to do too much at once in every step, it gets confused and it has more risk of hallucinations. So that's a big piece of it. And then the last bit is security. A big part of what our customers need is to make sure that they have control over their data, especially when we're working with enterprise customers in the fintech space. And we have to build infrastructure to accommodate that. So, for example, we give every customer a private instance of our platform that only has their data in it. The only time the data leaves the platform is to go to Claude, but Anthropic has actually provided a SOC 2 compliant LLM, which is really great. We are also looking at rolling out our own fine-tuned version of an open source language model for customers that want full control or having an on-prem solution where even the model is in their control. And then with some customers, they may already have a private instance of GPT-4 that they've already done the security review for, that they've put into their secure kind of enclave, or that they have as a private instance on Azure or in their own infrastructure. And we can actually just run our agent using that LLM. And so those are ways that we optimize security, besides all of the stuff you should do at any company when you're thinking about security around SOC 2 and stuff like that too.
Very cool. On that note, really curious about interop between foundation models. Obviously, you built everything for Claude 2 initially. You mentioned starting to fine-tune open source models, potentially bring your own keys. How are you finding managing a consistent, quality, reliable experience across foundation models in parallel?
So a big part of that is making sure, one, we have the infrastructure to, as I mentioned earlier, error correct and steer the agent consistently. And so we built a lot of infrastructure around how our tools work, around how our agents work to make all the prompts consistent. And so we're removing that as a potential vector for creating differences between the agents. The other part is that we test different models consistently, so we know which ones work well with our agents and which ones don't. And that way, when a customer comes to us and has a preference on a model, we can also tell them what we're compatible with. So for example, GPT-4 is one that works really well with our agents, but it's just a bit slower than Anthropic. So it just means if you want to use GPT-4, your processes are going to take longer to complete.
What's your biggest scar tissue, AJ?
Biggest scar tissue? Wow. I think probably it's the journey of going from demo to production. I think pretty much everyone in the space has probably underestimated the amount of work that it takes to make it happen. And certainly we were very ambitious with our timelines initially of like, okay, in 4 weeks, we're going to have this demo agent working in production reliably for our customers. And it just took much longer. And the reason why is because, well, at first it's just this whack-a-mole of fixing all these little things to just get everything working reliably, as I mentioned before. But then there's a lot of larger architectural decisions and kind of decisions around how you approach using LLMs that you need to iterate your way through to find. And so that just takes time. What I've realized is that, one, patience, right? A lot of what we're doing is the bleeding edge. if you think about applied AI, it's this very new field that didn't exist essentially really in its current form a year ago. A lot of the AI was done in research labs or in machine learning teams or in data science teams. It wasn't done by most like regular software engineers, right? But now because of LLMs, any software engineer has access to AI and they can apply it in a product. But also because of that, everything we're doing is kind of new, right? AI agents or thinking about how to do chain of thought reasoning or thinking about how to error correct. It's all kind of net new stuff, right? So you have to have a lot of patience. You have to have a lot of openness to failing and to iterating quickly. And I think for me, it's not so much scar tissue as much as realizing that and having the patience to do that, while also making sure we're constantly focused on delivering for our customers. We're not a research team. We're not trying to do research for the sake of it. We're always focused on how to build an end product, but also just knowing that the iterations are going to take time and we have to quickly learn and improve.
That makes sense. I know we've chatted before about some very minute realizations that were actually extremely impactful, like on the number of tools you could use, for example. Curious, any other very practical lessons you've learned like that?
Some of the practical lessons I would say is when you're starting out, I would just try and get to a prototype as quickly as possible. I think we built the first prototype of our agent like a week or two. And I was pretty rusty. I'd been in product for like over a decade. So coming back to writing Python code again was pretty fun. But I think having that kind of focus on acting with urgency and building something as quickly as possible to really test your hypothesis is valuable. I think you want to, as much as possible, stand on the shoulders of giants. While AI agents and applied AI is still fairly new, there's a lot of really great research out there and great frameworks you can use to get started. Everything from LangChain to vector databases to using frameworks like React for running agents. All of these are available things you can start experimenting with at the beginning. And so I would say as much as possible, use the knowledge that's available before you start stuff yourself. And then once you've proven your hypothesis, then you can start experimenting with how do you make it customized for your particular use case.
Awesome. Do you see the future being a small number of foundation models like OpenAI, Anthropic, that people continue to prompt engineer and build on top of? Do you see a future where everyone's fine-tuning their own model? Do you see something else? Just curious what you think the landscape is going to look like.
I certainly hope it's going to be the latter and not the former. I think having a few companies that have the keys to intelligence is probably not a good outcome, both for the technology industry and humanity in general. I am really, really impressed and continue to be impressed by how much is happening in the open source world. I thought at the beginning of this year that open source would not be able to catch up with foundational models because the amount of investment you need to make to build a foundational model kind of exponentially increases as you get more and more tokens and more data. So it's really hard every year for an open source model to catch up. But when you see companies like Facebook, for example, or Meta, as they call it now, building these open source models, using all of that capital they have and then making it available to everyone, that to me is really, really, really powerful. And I don't think I fully grokked how much providing an open source foundational model and then doing fine tuning is actually a really great way of building the open source community, because that initial capital investment of building the foundational model is very high, right? To build Llama 2, for example, but then fine tuning is actually very cheap. And so because of that, you've got now a bunch of these different companies that have more capital or maybe even nation states that are building these foundational models and then making them available as open source, right? And then any customer can come in and fine tune for thousands, hundreds of thousands, or even hundreds of dollars, depending on their use case, one of these models. And that to me, I think is going to create this massive proliferation of verticalized models that are really good at very specific use cases. And I think that's going to result in innovation happening that we can't predict right now, but also means that you won't have just 3 or 4 models that rule them all. I think for the enterprise, there'll certainly be models of choice that kind of have ticked all the boxes for security, compliance, privacy, et cetera, that many enterprises will use. But I think for startups, it's going to be different. I think there's going to be a lot of options available. I think the other piece as well is the proliferation of all of these open source models and the ability for anyone to come in and fine tune a model, and all the machine learning ops startups that now exist to help you fine tune a model means that the next innovation that we might see, the next kind of major step in intelligence that we see could come from the open source, could come from the research community, may not even come from one of these big labs.
Where'd you start? How'd you get into AI?
I came to Silicon Valley in 2008 to start a real-time search engine. That's where I got into this idea of organizing data before AI was really cool. And we did that. We did YC a long time ago. It was the last Boston batch. That company got acquired by Google, and that's where I started my product career as a PM on the now sadly defunct Google Plus. And after spending 3.5 years at Google and learning what it is to do product management, which is very different from being a founder, I took some time out, worked on another kind of data-related startup, but it was much more in a passion area of mine, which is music. So we created this cool music recommendation product for DJs. It would take all of the playlists on the internet of famous DJ set lists, and it would turn it into this collaborative filtering algorithm, something similar to how Spotify makes music recommendations, but geared towards DJs to help them work out what song to play next. Then after that, I ended up joining Coinbase. So I got there just around the time that crypto started taking off. This was in 2017. And that's where I really got into fintech as a kind of industry and area. Learned a lot about these complex back office things like fraud controls and compliance and risk management, which at the time was completely alien to me because I had been a consumer PM prior to that. And through that journey, ended up at Brex. Brex is a corporate card company. They focus on venture-backed startups. We're expanding to small businesses at this time. And me and my now co-founder ran the platform team there, where we helped Brex scale about 10x in a year. Really, it was that experience that led us to the startup we're doing now. During that time, we helped Brex scale a lot of its back office services. Brex were onboarding all these customers, and they had to work out how to make sure that the customers were compliant. These were business customers. Had to underwrite their business to provide them with a credit card. Had to work out how to move money for them. Had to do operational work, customer support, all these different areas. And there was this last mile of stuff that was really hard to automate. There was all these manual processes at Brex. So much so that at one point we had a backlog of 2,000 customers that were waiting to be onboarded just because we had to do these manual reviews when we onboarded them. And we really saw the limits of what machine learning and automation and traditional RPA, robotic process automation, internal tools could do in order to really automate these processes. And there was always this last bit of automation that couldn't be done because it required human judgment and expertise. And that's really what inspired our company, Parcha.
Super cool. Well, AJ, we so appreciate you joining us today. Super insightful as always. For folks who haven't seen already, we definitely recommend checking AJ's podcast out, Hitchhiker's Guide to AI, and finding AJ on social as well.
Awesome. Yeah, you can find me Twitter_AJ. And then our website is parcha.ai. If you are looking for agents to instantly automate your operations and compliance, please do check us out.
And as always, this is a new experiment, this podcast. So we'd love your feedback on what you want to see more of, see less of. And stay tuned for another great episode next week of Bits and Bots. Thanks so much.